Welcome to this Business Central launch event about what's new in ALGO for GitHub on security. My name is Freddie Christiansen, Technical Evangelist out of Microsoft, and I have with me...
Thank you, Freddie. My name is Maria Jelezova, and I also work on ALGO for GitHub with Freddie.
And we'll jump right into the agenda here and talk about deprecations. Wow. Talking about deprecations is kind of like talking about what's not new, right? But it's actually not about so much about what's deprecated. It's more about having a website now where we're explaining what's going to be deprecated in the future. So there are some changes in effect that will stop working after October 1st this year. And you'll find those here. You'll also get warnings in the build if you're using these features. So consult this site, AKMS, ALGO Deprecations, to see what's being deprecated in the near future. Beside that, there is also a AKMS link called AKMS ALGO Release Notes. Clicking at this one will take you to the release notes. Well, no wonder. Version 6.4 just released, and the topmost release notes is from version 6.4. If you'll find features described on top of version 6.4, they will not be included in version 6.4, meaning that you probably have to run preview, or they are not even in preview yet, but you can ask us that on GitHub if you're in doubt. But if they're not underneath a version number here in the release notes, they haven't been released yet in a full version. So next up, talking about Azure Trusted Signing. Maria, take it away.
Hi, everybody. I'm going to walk you through what Azure Trusted Signing is and how ALGO is integrated with it. Just the key takeaway for Azure Trusted Signing is that it's the natural evolution of the signing process, which completely eliminates the need to manually rotate certificates, as well as storing secrets to access these certificates. It is a service that Azure provides, so we get to have the natural experience. And there is also a link to the official documentation where you can read more about it. Now, off to the steps on how to set it up with ALGO. First and foremost, you need to create the service on Azure, which is called Azure Trusted Signing account. Then you need to perform an identity validation. And this is the hardest step of the process, where you need to verify indeed that you are who you say you are. And because there's going to be certificates issued on your name, and it needs to be made sure that this is the right identity for it. Once you have at least one identity validation request completed, you can create a certificate profile where you will be able to create certificates for your signing purpose, purposes. After that, you need to make the connection to GitHub, and the first step is to create a managed identity. The needed role or permission for that is Trusted Signing Certificate Profile Signer. And creating federated credentials is where you completely make the link to GitHub. On ALGO site, you only need to create a secret Azure credentials, which you might already have, because it's also used for integrating with other Azure services, such as Key Vaults. And lastly, you need to create a trusted signing setting for your GitHub repository, which looks like this. It has an endpoint, account, and certificate profile. Setting up this will make the signing process seamless throughout all your GitHub repository that utilize this feature.
Next up is GitHub App Authentication. So let me explain quickly what that is. As you know, we require you to create a personal access token, or a secret that contains a personal access token. In the beginning, we had the classic personal access tokens that impersonate the user, have same access to all repositories and organizations that the user have, and are used to authenticate to the APIs and so forth. And that's really, security-wise, it's a problem. So we created the fine-grained personal access token. It still impersonates a user, but it's now scoped to one organization and a select repositories. Still imposes some security risk if exposed to an evil person or whatever. What we have now is GitHub App Authentication. And why does that differentiate? What you have now in your secret is not the actual access token. In your secret, you have an app ID and a private key. And that combination is used to create a short-lived access token. And the only thing that ever leaves the GitHub runner is the short-lived access token. That's typically living for an hour. And with that, you can only do the stuff that this access token was created for. So if we create an access token for reading a repository, that's what you can do with that access token if it ever gets exposed. Again, here, there's no impersonation. It's a bot, or it's an automation. It's the app. And it's scoped to one organization and a select repositories, and you can do exactly, you can get the permissions for the access token that the app is set up to be able to give you. There's one scenario that doesn't work, that's GitHub packages. So that's a feature that GitHub is missing. What you can do there is you can create a specific personal access token that only has packages read-write and nothing else. That would actually, that would solve that problem. But let's have a look at the GitHub App Authentication and see how that actually looks. There's a number of runs here, and if we look at this one, the very first update ALGO system files I ran, manually run by Freddy DK, and the commit that resolved from that workflow run, the update ALGO system files here, is a commit pushed by Freddy DK. So that is done by my personal access token. That's my user that was running this one, and it was my user that pushed this one. So that was done by GH token workflow that was impersonating me. The next one I ran here is done manually run by Freddy DK, but the subsequent commit here is pushed by ALGO Authentication, and that's a bot. That is the GitHub app. Let's have a look at this one, which actually ran this workflow. And click here, look into the update ALGO system files. And what happens here is that it gets the app info and it gets a token response and saying, I want access to this repository and I want the permissions to read these different things. And when I then discover that, yes, we have to actually update the system files, then later on, we're going to get a new token, which is for write, read, and write, in order to update or create the pull request that updates our ALGO system files in this repository. So at any time, the access token that we use does not have more permissions than it actually needs to have. So let's go back to this one and talk about embed secrets in installApps and installTestApps. We had a workshop with a partner that was using ALGO or was in the process of setting up ALGO for their repositories. And one of the things they told us was that they had, like, right there in source code pointers to blobs that were like in a secure storage area, meaning there was like a SARS token there in clear text. Well, it might be a read token, it might not actually be a problem, but we decided that should not happen. We should not have secrets in clear text. So what we did was we added a feature that enables you to, instead of having an installApps where you have like, oh, this is Dropbox, but anyway, where you have an URL key or whatever, now you can actually have a secret name right there in your installApps that allows you to store the SARS token or the URL key or the entire URL away in a secret so that you never see that one in your logs or anything like that. Let's just have a quick look at how that looks. This one. Looking at the build here, we'll see that looking at the parameters, it should have a list of installApps, which is just some stars because it's a secret. Later on, we'll be able to see that when it's installing the apps, it's actually installing the Bing Maps app here, but we cannot see where it came from because the URL was a secret, obviously. So, with that, back to Maria.
Thank you, Freddie. The last section of this presentation is about running AOGO for GitHub on multiple branches. Now, one of the things we recommend people do when they use AOGO is to always use the latest version or to run updates as soon as they're available. Now, we highly recommend that, but we also know that the workflow itself can only be run one branch at a time. And with the latest version, 6.4, we actually added the capability to do that, to update AOGO system files on multiple branches at a time. What we also recommend is to run AOGO or update AOGO system files on a schedule. And we also acknowledge that there is a limitation on GitHub that doesn't allow you to do that for multiple branches that are not the default branch. So that's why we added a new setting called Workflow Schedule, where you can define your cron schedule as well as list of branches to include when running the workflow. Now, off to a short demo where I'm going to demonstrate quickly. When you update AOGO system files, there is a new field where you can specify a list of branches to update. You can use wildcards, and you can use as many branches as the input allows you. I'm not going to wait for this to finish. I'm just going to show you what the result is. You can verify on the repository that there are indeed like 2 branches that match these patterns, and the workflow runs on both of them. With that, thanks for watching the video, and see you next time.
Thank you.